Now let's try this way. So the array and then create another variable, object E with 10 elements. And then let's do E equal D, which is a assignment. And then let's see what's happening there. Compile the program, and then as I run it, it says error for object pointer being freed was not allocated. So we have some pointer management, the dynamic memory allocation management error here. This is a Mac computer, so if you're using Windows, some other error message will show up, not like this. The Linux a little bit different. So what's happening is as follows. Let's trace the program and let's see why we have a pointer being freed was not allocated issue there. So let's run the debugger. Then let's do step over. There's no problem so far. And then all the statements are done. So we are at the end of the main function. So remember that the variables or object created within a function block, at the function block ends, the object will die. Actually, the object dies is a reverse order of the creation. So D is created. So D constructor is called when this is created. Now we have E calls a constructor to create it. Now at the end of the function, E dies first. So destructor of E for E will be called, and then destructor for D will be called. So destructor call is a reverse order of a constructor. So it's there. So that's what's happening. So let's try to trace that. So at this moment, let's do step into to trace the program execution. So what we do is step into. Then, as we expect, destruct is called, and destructor being called. Let's see which destruct is being is the first one is destructor for E is called. And then let's try to remember the address. This is address for object E. So let's remember the last few digits, F648. So let me write it down. So E address is something F648. That's being freed. So let's do step over. This is done. Step over. We are at the end of the main function. Now destructor of D should be called. Step into. Another destructor is called. And then destructor, we can tell that there's a different address. So D and E are quite different, and the destructor is called. However, if we continue, the exception occurred, so the error occurred. So what that is, and let me show you one more time to actually get the idea of this one. So start the debugger again. Then step over, and at the end of the main function, step into. So in this, which is object E, this first being destroyed. If we unfold that P array, so object E is at address this one, but in this object E we have a P array is pointing to some dynamically created array, and an address of which is something all zeros. So we have 3000000 is the address of a dynamically created memory for this is a 10 element double array. That's what you got. And then let's continue. Step over, and then step into. Now destructor of object D is called. As we unfold P array somehow has exactly the same address of what E array had. So here we have a object D, and then P array. The value, as you can see, is the same as what we had for E. So P array is pointing to the same array dynamically created. And then using the same array, it tries to free the memory again. That's the message. Pointer being freed. This same pointer, which has been deallocated already, is trying to deallocate it again. So that's a pointer being freed, was not allocated error message. So something's going on here. So we need to understand what that is as follows. In classes, object like D and E, as we do assignment, what's happening is, let me erase the screen. So as you do assignment between two class objects, what's happening is there's a default behavior of assignment. When you use assignment, there's a default behavior. That default behavior is called shallow copy, or it is a member wise assignment. Member-wise assignment is between two objects. Each member is copied. That's the assignment. So here, when object D is created, it has a capacity and then P array. Capacity and P array. When object E is created, it has a capacity and then P array. And then as I do assignment, what's happening is a shallow copy or member-wise assignment. So whatever is in C capacity, that is copied. So it was 10, 10 is copied. Whatever is in P array, that's the address of the dynamically created array. So here's address is stored there. And whatever is here, that value is copied into the corresponding member so that it ends up sharing the same, pointing to the same array, so that when this structure is called, it is freed twice, so that we have an error message. So which means the default behavior of assignment is not sufficient when you use assignment operation between two objects of a class type. So in the earlier lesson, when we deal with the fraction, this did not happen, and then the assignment we used the default behavior was all okay, but here it is not okay. So when do we need overriding the in other words, when is not sufficient to use a default behavior of assignment is if class has a member which is a pointer for which the dynamic memory allocation happens. So if a class has any member which is a pointer and eventually dynamic memory allocation happens, then the default behavior of assignment is not sufficient. So you have to overload the assignment operator so that we can avoid sharing the dynamically created memory. So let's learn how to do so in next video.